Well, good morning, everybody, or good afternoon, I should say. Probably a little bit of both. I'm Randy Andracki. I'm one of the solution specialists here at ImagineIt, located in our Chicago office. I've been working with the Autodesk products for over 20 years. So specifically in the mechanical MSD machine design industry. Today's presentation is going to be around 3D annotations. And what I'm going to do here, first of all, is let's just go through our agenda. So this topic covers a wide variety of functionality within Inventor, which I'll be showing you. So let's just review our agenda here. So what we're going to start with, we're going to start talking about Inventor's AnyCAD. And this is not a new term, as many of you most likely have heard something about this in the past, around maybe translations and importing other CAD data. It's evolved over the past few versions of Inventor, so hopefully I'll be able to show you something new. For those of you who haven't heard of AnyCAD, it is about importing and translations, but it's also about Inventor's ability to be able to open other CAD models as a reference file. So we'll talk about how Inventor can work with virtually any CAD system. All right. Models that were made using other CAD programs like CATIA or NX, for example, and neutral CAD files such as STEP, SAT, JT, and several others can all be open with Inventor. We'll talk about both methods for bringing other CAD data into your Inventor design as a reference model and importing, how they differ, and the benefits of one over the other. So then we'll move into reviewing 3D annotations for parts and assemblies. This is where we can generate additional design information directly in our 3D models and assemblies. For example, like GD and T. You see in the slide here's dimensions and tolerances, feature control symbols, and we'll get into a tolerance advisor as well. So essentially, no need, if you want to say, no need to create drawings if you don't have to. So because any critical information that applies to manufacturing can actually be added to the model here. So, but this is then we'll move into our tolerance stack analysis. And for the last thing, and tolerance stack analysis will leverage several of the annotations that we put into our models. The last thing we'll talk about is how we imagine it can support you to learn these new products and or these new tools, and we do that through our productivity now. So we'll touch base on that as well for you. So moving on, starting out with the first part of our presentation, Inventor's AnyCAD. In today's design environment, we're always having to deal with CAD data generated from multiple CAD programs, whether it be in the native CAD format or in neutral CAD format. With Inventor's AnyCAD functionality, we can open several file types as a reference model. Okay. What this means is an associative file link is established when opening a native CAD file. So we see all the various types of CAD files here that we can open. Should we receive an update to one of those referenced files and replace the original with the updated file, all changes from the updates will be reflected in your design. So that's why we say it is a reference and it is an associative, because even though it's being referenced, for those of you that have used AutoCAD, think of an X reference, for example. Same goes with STEP. STEP is a neutral file, but that can also be opened as a reference in Inventor. So if the design is at a stage where frequent changes are taking place, you may choose to use the reference option. And we'll show the dialogues here. We'll get into all of this. If they can be, the reference option can be converted to an import simply by breaking the link, and we'll get into that. Now, we've been talking so far about working with other CAD files from other CAD systems, be it the native CATIA, STEP, NX, Solid Edge, or a neutral CAD file. But we're also we're also many times as we're working with Inventor, we might get maybe I'm using Inventor 2017, and I got a file from my customer who has Inventor 2018. I need to be able to reference their files, their 2018 Inventor files, into my 2017. I can do that now. I can reference 2019 into 2018, 2020 into 2019. To do that, you just need the latest version of your Inventor version. Okay, so 2017.4 reads a 2018 file. 2018.3 reads a 2019 file. So a lot of file sharing here is what we're talking about. Because we're talking about so many different file types, what can we do with each of them? So we put this chart together, call it our Inventor translators, and in there we're letting you know whether a file can be brought in as a reference, or if it has to convert, or if it can do both. So the first column here, we're looking at the file type that we can work on, and what we can do with a step file. Well, we can import and we can export step files, and we can open them as a reference file. So if I get an update to that step file, it'll update automatically, or I can simply import it. A variety of the files: Alias, CATIA, Solid Edge. If you look in this column here, or for the 2020 Inventor, this column here, you can see which files come in as can be brought in as a reference or as an import, and others, and those that can only come in as an import. So nice reference chart that you might want to print it out, and we can get this to you if you'd like to have a copy of this. So have this taped up on your wall somewhere where you can refer to it. We've been talking a lot about utilizing data from multiple CAD programs. As we attempt to open a part or assembly file, for example, from CATIA or NX, we're presented with a dialog where we decide if we want to import or convert the file. So these are all the file types that we can bring in into an Inventor assembly and or part. And can they brought and use the chart before using not that one. Using this chart, you can determine if it can be brought in as a reference file or if you have to import it. So, and here's our dialog where we choose what we want to do. So if data is referenced, the reference file name will appear in the browser. So in this particular case, I see that, okay, this was a step file that was referenced in. If I received an updated version of that step file and replaced the original with the new version, I'll get the familiar lightning bolt that Inventor uses, telling us that, hey, you need to update your design, something has changed, okay? Also, we see in this particular case, we're talking about saving files. So previously we were talking about bringing data into Inventor. Well, what if I need to save data and send it to a customer, and they need it as Pro-E or they need it as CATIA V5? Well, from Inventor we can write to CATIA V5 and Pro Engineer, and of course these other file types, which most of you are probably, many of you are probably familiar with already. So what can we do with geometry once it's been brought into or converted into an Inventor file? We don't have a history tree where we have extrusions, revolutions, holes, and so on. So after importing another CAD file into our design, we can use Inventor's direct edit or solid edit commands to make changes. Any neutral file that is imported can be modified in a variety of ways, which I'll be showing you in a moment. I can delete these fillets if I want to using the either of these two commands. I can remove these chamfers, and the edges will be squared off. even delete the holes if I need to. So there's a lot that can be done with a model, even though it's been imported and it doesn't have a feature tree to work with. Another thing that you may not be aware of, and you've seen it on the screen here, is feature recognition. It is available with Inventor. It's not a released feature, it's a beta feature. So we have an app that we can download, and the application was developed by Autodesk, and they call it just that, feature recognition. And like I said, it's a beta app, so use it with caution. And it can be downloaded from this app, from this link here, and again, we can get that to you for those of you that are interested in it. Or if you Google Inventor feature recognition, you will be presented with a page where you will be able to get to this location here. With feature recognition, when you right-click over the solid in your browser tree, you'll have a new item called Recognize Features. And what you can do, we'll get a new tab, and I'll show that to you in just a moment, where we can do automatic feature recognition, or we can recognize an extruded or revolved feature, holes, shells, sweeps, these 9 feature types. So what I'm going to do is let's get into the first part of our presentation. And what I'm going to do here is I'm actually going to use all 3 of these features. I'm going to do an edit solid, I'll do some feature recognition, and I'll do some direct editing, all on the same model. I'm actually going to work on this particular model here. So let's get into our presentation. And here we are. Now, first of all, let's talk. I assume everybody can see my screen. I have the correct screen shared. So let's talk about 2 files that I have opened here. First of all, I'm going to go to my range here in the lower left-hand and lower right-hand corner, and let's just tile these out vertically. Oh, I don't want that window there. There we go. And let's look what the difference is between these 2 files. This file here was brought in using the import method. Notice how the icons in the browser are actual parts. If I look at the part, go to my modeling tab right here, I see that, okay, yeah, there is a part body there. I can activate that part, and what can I do with it? Oh, I can recognize features. I can do some editing to it if I would like. But we're not going to do anything to this one, because I just want to talk about the difference between these 2 file structures, the difference between a referenced file and an imported file. So if I take a look at this file here, so named it accordingly, so you know, okay, it's the same thing, but it's referenced. But notice how these are not features. This is one part that was brought in, and it's in a little assembly, and these are all the parts that go underneath it. So what I can do with this, if I want to change that to an imported part, because I'm past the stage of design where we're getting frequent changes, and we're ready to start solidifying our design. So let's lock down some of these changes. So I could suppress the link, which will prevent it from updating. So if we receive any updated files, updated step file, I'm sorry, this was a CATIA file is what it was. This was actually a CATIA file that was brought in. Both of these, the same CATIA file that was brought in in a different way though. Suppressing the link will simply prevent this model from updating. Break the link, but I can unsuppress, so then updates will then continue on. Now, if I break the link, it'll be just like an import. This file here, the browser tree structure will look exactly like this one here now. All right. So if I take a look, so essentially we don't go into edit, import. Went onto my other monitor. Here we go, and we don't have the option to say convert it. We simply break the link like I showed you earlier. So this is that dialog that I showed you earlier when we were in the PowerPoint. So bringing in CATIA parts, and I could do the same with an NX. If I say open and I change my file type or take a look at my file types, I could, well, I could go to any of these file types that I would like. Fusion, SolidWorks, Rhino, Revit, Parasolid. But in this case, what I'm going to do to continue and start talking about some of the feature recognition and editing of these solids, first of all, as we move through the annotation process, let me go to my vault here. And let's open up a step file. So I'm going to change my file selection to step here. And because I'm opening up a step file into a new part, the only choice is to import it. The reference option I didn't mention is only available when you're working in an assembly. Part has to exist. So a part can't be a reference to itself. It can only be a reference to an assembly. So let's close this one out. Actually, yeah, let's close this one out. We won't keep that. I don't need it anymore. And do I need that other spark plug? No, I'll get rid of the other spark plug. All right. So this part was opened from a step file. And first of all, notice that it came in with some dimensional information. There's no tree structure, so there are no features, so there are no feature dimensions. What these dimensions are is these were annotations, something we're going to talk about when we go to the Annotate tab here. And this is the 3D annotations. Well, whoever made this step file had some annotations on it that they included when they created the step file. In this particular, we'll talk more about creating them and how we can add them and use them to share with other applications. In this case, I don't need these particular annotations, so I'm just going to delete them because I want to talk about modifying this geometry a little bit still. So I could either turn these off. In this case, I'm going to just delete them though. All right, and let's just get our model oriented here the way I'm used to it. It's my habit. Now, what can we do here? First things first. Let's talk. If I right-click over this feature, I have recognized features. And by the way, this is just a plugin, this feature recognition. If I go to my Environments tab, you have to go to Add-ins, and once you've installed it, and you'll have to tell the Inventor that you always want it loaded automatically or load it upon request. So this is part of the installation process. It's a very small application. But what we're going to do first is we're not going to do any feature recognition. Let's talk about a direct edit command. Let's talk about edit solid first. Because I'd like to, let's just show you how we can do some solid editing or some editing to this model here, even though there are no features in it. See, I can just pick, and if I hold my control key down now, we're all familiar with control pick. Rotate my model around. And pick those faces there. I might want to delete these two chamfers here, or maybe the fillets here. So I have all these features that I'd like to remove. When I right click, I'll simply say go ahead and delete them, and they're gone. When I finish that off, finish that base solid, notice there's no recognition of that transaction, of that process that I just went through. I'll talk about why I'm pointing this out to you in a moment. So now let's go, and I'd like to convert. I still can't, I can change if I wanted to. I could use my edit solid, and I could say let's take this face and let's move it. And I can move it down or move it up, whichever way I'd like it to go. But instead, what I'm going to do, so again, another way to make the change, but instead what I'm going to do, I need to make it a little bit smaller, change its size, and also change its depth at the same time. So it's easier if I simply say, let's recognize this as a feature now. And now, notice how we have our feature recognition tab with the 9 features we could create. Suggestion, earlier I mentioned it is a beta program, so nice that automatic feature recognition is an objective, is a goal, but I'm going to focus on smaller pieces of the pie at this point and simply say, let's recognize an extruded feature, and when I pick it, I'll say OK, and I see extrusion appear here. When I say finish, go ahead and create that. I now have a feature with a sketch, which I can edit that sketch, and I can add dimensions to it if I would like. Maybe I need to project an edge and change its location or move it in this way, whatever we need to do with it. All right. But when I say OK, now that is a feature with dimensions. Now I could do the same thing. Now pay attention to that slot. When I say recognize features, watch what happens to that slot now. Disappears. I'll talk about why it disappeared in a moment. But let's go and let's recognize some of the holes. I could pick that hole and can only pick one at a time, or in this case, I can say recognize similar, and it found all those holes. All right, and go ahead and apply that. Let's do the same thing here. Let's recognize these holes where I removed those chamfers from. Let's apply that. And let's see if this will say we're finished. Go ahead and generate and recognize those features. And I now have all the holes. So it didn't create a pattern. If you were building these holes using your parametric features within the Inventor, you probably would have created one hole and then patterned it around, and the same thing here. But expediency is everything. The longer we take to get the model created the way we need it, the more expensive it is. So the quickest way is the best way, as long as we get to the same bottom line that we need to get to. Now, in this case, I also need to rotate these holes because these holes need to be rotated 30 degrees. So I could go in and I can edit each one of these sketches, which would be not the desired way. So I'm going to go back to this feature here, and I'm going to say, let's edit this feature. I'm sorry, direct edit. Let's use direct edit. And with direct edit, what I can do is I can move a face. So I could pick on that face and I can move it down or make it deeper or move it up. I can make this hole bigger or smaller. I can scale features. I can delete faces like I did before. A lot of things I could do. In this case, I'm going to rotate. And I'm going to pick on, I have to pick each face. I also have to pick the back face as well. All right. Let's see, did I get everything? Looks like I got everything. So let's take this and let's drag it to the center here. And how can I rotate? I can, if I pick on the arrow, it allows me to control which axis I rotate about. Well, this is, I know why my mouse was falling off the mouse pad there. I want to rotate about this axis, and as I drag, okay, yeah, so the holes are moving. If they didn't move, that means I probably missed one of the back bottoms of the holes, or I missed one of the holes itself, or mispicked. So it wouldn't let me partially pick some of the hole features or a portion of the hole and then rotate the whole thing. I have to grab the entire hole. So here I'll say, well, we're not going to work in radians. Can anybody calculate what 30 degrees is in radians? Or I'll just type 30 degrees here. So, and we'll say OK to that, and OK to that. So now I've just done quite a few things here using edit solid, recognize features, and direct edit. So a lot more that that you may have thought you can do with what many of us a few years back might have called a dumb solid. There's really no such thing as a dumb solid anymore, especially when you're working in Inventor. Now, let me show you one thing. Notice this, when I remember earlier when I deleted the fillets in this slot here, I used the solid edit command. You see no transaction in the browser of that operation, but you do with the direct edit. Now, where do I get the recognize feature command from? I have to go to the base solid. So that functionality starts all the way up here, which means it will turn off all these features. All right. And I picked the wrong command. Recognize features, and it will turn off these features, so I could then pick additional features. If, for example, I wanted to add this hole in there, I could do that, or I could just exit now. So now, and not to show flaws, but because you're going to want to go back to your desk and use, and some of you are going to download the Recognize Feature application. Notice the direct edit is gone. All right, so that's why I used the edit solid, because I knew it was going to remove that from there. So understanding how feature recognition works is half the battle of using it. All right, if I right click, if I opened up a solid model that I created from scratch in Inventor with all the extrudes and so on, this command wouldn't appear there. It only appears there because it knows that there's a base solid as the very first feature. So that's what goes on. So that's a little bit on the ability to be able to work with any CAD inside of Inventor. All right, so hopefully that was enlightening for a lot of us. So I've got to pick up the pace here a little bit, because I see we've got we're at the bottom of the hour here. So let's get back into our presentation here, and actually I'll open up my files. So I'm just going to close this up, and I'll open up my next group of files here. We'll just go right to the next part of the presentation, which is going to be 3D annotations. All right, so 3D annotations were first released with Inventor 2018, so they've been around just a couple years. MBD, model-based definition. It's a tool set in Inventor providing the ability for adding annotations such as GD&T, geometric dimensioning and tolerancing, general notations that you need to add in, as you see in the figure here, whole notes maybe, in the 3D model. Imagine the model that we were in. I can add notes to it, and I meant to do that actually for you, but I saw the time that where we were at on the clock, so I didn't want to do that. So where can these annotations be used? So here's an example where I did add some annotations. Actually, we're going to an example here. I just made some general notes. Change this 0.2 radius to 0.15. So maybe it's an engineering manager who marked up this model, this 3D model, and he's sending that step file to his consultant, who's then going to import it. He'll see these annotations when he opens up that step file. If you remember, when I opened that step file in Inventor here, it had annotations in it. All right, so this could be part of the reason for annotating. A big part of why annotations are used is they add those critical GD&T in engineering and manufacturing. Can add those critical G, D, and T symbols, flatness, surface texture, critical tolerances for press fits. 3D annotations allow us to capture our critical design intent for manufacturing. Using the annotations could also provide a means for eliminating the need for having to create a 2D drawing. If I have everything in the model and I just want to manufacture a part, why should I go and start making drawings for it also? I've captured everything in that one model. However, if drawings are needed, annotations that we create in our models can be retrieved in drawing views. Parts and assemblies. Annotations can be added to both parts and assemblies. And I've mentioned that, but I've only showed you in a part so far. Drafting knowledge. Many times a drafter might not know what critical surface finishes are required, or geometric dimensions are required, or what tolerances are required for press fits and so on. So an engineer may add those. It's an excellent tool where an engineer can use the annotation to add those critical bits of information before passing the data along to drafting, or maybe a third-party outside service to generate the drawings for us. For STEP, annotations can be exported to a STEP file, a 242 type STEP file. They can also be exported to 3DPF and retrieved, exported for, if we export as a STEP 242, we can retrieve them in CNC programs that have the ability to read STEP 242 files. And also in the side of tolerance analysis, which is the very last part of this presentation. We're going to talk about that as well. So it's all about making a more complete data set that can be shared and leveraged. So a variety of reasons for annotating at the 3D part and assembly levels. So, and we've talked a lot about some of these annotations already. I went through what several types are, so I won't talk about all of these at this point. Let's get into some of the other benefits that you get, and I'll start showing you some of this functionality. So annotations on a 3D model, as mentioned, they describe the tolerances and controls, the allowable variation in the model that's permitted during the manufacturing process. We see in the browser how the annotations are managed by grouping them together into folders. Instead of having all these features appear all over the browser, certain types of annotations go in the annotations folder, other types go in the tolerance features folder, and there are yet other folders that are generated. So the software keeps them organized for us, nice and easy, real well, so we can just simply turn them off if we need to, or right-click over them and edit them. Again, we'll get into that in a moment. We also see how the tolerance advisor, in this case, this advisor is something that you're going to start to see in my browser. So it's another tab that we're going to have at the top of our browser. We have modeling, assembly, vault. Well, we'll see tolerance advisor. And as I'm adding G, D, and T type symbology to my 3D part, this Inventor is doing the best job it can to tell me, have I fully constrained that bit of information, or have I told the system parallel to A or parallel to something, but haven't specified what that something is? Well, we need to be able to specify both sides of the parallel note. So in this case, it is fully constrained. We'll also be told if something's partially constrained, unconstrained, and so on. So I mentioned earlier that in many cases, we're not just going to drop creating drawings. I mean, the potential is there to where we don't always have to create a drawing, but when the need is there, if I've already added some annotations into the 3D model, I don't want to have to recreate that information. I want my drafter, or I want the outside consultant who's doing the detailing for us to be able to retrieve that information. So we can retrieve annotations by editing each view at the assembly level and at the part level. Okay, so let's get into the next part of our presentation here. So let's get into Inventor, and let's open up. Let's go to our vault and open up. I'm still looking for step files. I want to look all for Inventor data now. And let's see, so let's open up these two files and these two files here, and we'll work with them. Open this data up from my vault. I have everything vaulted using Vault Professional here. All right, so first things first. So in our browser tree, notice no folders. Well, no folders in terms of annotation. If I go to my annotation tab, I now have presented with dimension, whole note, surface texture. And let's just do some basic stuff here. Let's just create a dimension. If I pick on this hole and this hole, I get, let's pretend that I'm just going to mock up this model because manufacturing just needs a few pieces of information. I don't want to spend all a half hour detailing the whole thing, so I'm just going to put information that's critical to manufacturing and be done with it and share this with them. So put this out there. What can I do? I can add tolerances to it. I can make it a basic dimension, a reference dimension. I could add symmetrical or deviation type tolerances, and if I pick on the tolerance, I can change the precision of it. So now you start to see why. Okay, it makes sense why I want to be able to retrieve this data in my drawing too, should I have the need for that. So here's +5. This one's, we'll leave that at 0. And we'll say, okay, I can append some additional text also, whatever I want to have in there. So we'll say okay to that. I'm going to put a dimension from here, from this edge. I want a dimension to the top of this part. Now, I can put dimensional information at different orientations by hitting my tab key to rotate the text around to different options. And again, I get the same options that we had there, different fits, min, max options, and so on. But let's just leave it as the default, and we'll accept that for now. I'm gonna, if I pick on this edge here, well, I want it to be at the same plane as this dimension here. So if I hit my space bar, I can toggle the plane that it's on. If I hit my tab key, the tab key, I can rotate the dimension text around. So I have quite a bit of control as to how I place the dimension. Again, back to some of the adjustments that we could make. So placing dimensions and adjusting, and I can and let's go and let's add a whole note, whole or thread note. I'm going to pick on this thread because we want to make sure that should they pull this apart and the threads are bad, we want to make sure that they know what this thread type is. So we're gonna add that note in there. In this particular case, the note, notice where it's attaching to at the bottom, so it didn't attach to the most favorable place. So we'll deal with that in just a moment. Though here, let's make a whole note, and that is a 0.25 hole. I can change that to a through hole, add additional information in there should I need to. For this one, let's adjust it. So when I click over, right-click over these annotations, a few things I could do. First of all, I could change the annotation plane, and I want the annotation plane to actually be up here. All right, and let's accept that. I would like to toggle the alignment around. So again, back to where things are appearing a little more the way I'd like them to, so I don't have to look one direction for that dimension, another direction for that one, another direction for that one. Can keep things nice and tidy for manufacturing as well. Now, catch this. This will be nice. I mean, I remember when I was designing tooling, and we wanted to know what our min and max distances were. So I'm going to add another dimension from this surface to that surface. We'll put it out over here, and we'll keep that. And now, as I drag this down, our annotations update. If I drag it up, now I see my bottom and upper clearance. Or you can imagine in your design where this may play a good role for you. Now let's talk about the drawing aspect of this, because we're still working in a world where drawings are needed. Not all the time though, as you can see. So when I come to my drawing, I had the views created already. It's not about creating drawing views. You know how to do that. I'm sure you're experts at that. But I right-click over a view. Oh, sorry about that. Right-click over a drawing view, and I simply pick Retrieve Model Annotations. And any annotations that appeared on my other monitor, select the ones that I want, or just apply it, and it'll apply all of them. I can come to my next view, and it's displaying. Now you see why I made that cutout. I knew that was going to work out that way, so I conveniently had that view cut out there. All right. And I can tweak these so you see where maybe an engineer might put these annotations in to help expedite drafting when we're sending data over for detailing to the drafter or wherever that might go. As I update, the dimensions are as you would hope they would, which are maximum clearance. Let's edit this, and let's just put it that is max clearance. Go back to the drawing, and there we go. All right. So that's at the assembly level. Now let's talk about annotating at the part level, and where we're going to get into some tolerance advising, not tolerance analysis, but at the part level. So in a part file, again, back to this annotate tab, but the options are a little bit different, not exactly the same. I have a tolerance advisor, which displays in my browser tree. Now, one thing I didn't point out, go back to my assembly file here. Notice my annotations are all grouped together underneath one folder, so I could conveniently, I could turn off one, or I could turn them all off if need be. Can I right click? I don't remember. Yep, you can't do that from that particular folder though. Okay, so just pointing out the organization of these annotations so that they're not scattered all over your browser tree, and they go above your end of features marker. So, all right, back to the part, and let's start adding some dimensional information here. So go in and I can just pick some edges if I want to make sure that because we're going to rework a part, maybe I received this part from a customer and it needs to be reworked to a specific set of dimensions. So I use some of those editing tools that we covered earlier to edit the imported solid. So this model is now corrected to the dimensions that the customer needs. And I need to add on the dimensions to the areas that are going to change. You know about the types of tolerances and the precisions that we can specify for these, and I can drag them around wherever they need to be. If I wanted to, let's add maybe we want to know what our overall, because that's going to be important here. So we want to make sure that we have our overall, and this is just going to be a reference, and we're going to tell them it's our overall dimension, and we're just going to make it be a basic dimension, because that dimension should exist already, but we will be modifying the width of these feet. Or maybe I need to add a whole note in there. Because these features, if I use the feature recognition tool, I can use my whole note command. And hole note now comes back and says, oh, there's 6 of them. It's a 440 UNC by 0.22 deep. Okay, that's the thickness of the material. There's no plane to change, but I can tab through how I orient the text. Remember, the space key is the one that allows me to change planes. So, and let's accept the default there. Maybe in this particular case, we'll add one more hole note, and we'll add it to this feature here. And there we go. And it is 4 of them, and we're set. Now, next thing I want to do, let's add a feature control tolerance. Because what I want to do is I want to be able to start controlling this model here, or these edges, and I want to make sure that we're specifying how we need our parallelism and what the datum reference is. It's A. I could edit these. Maybe this needs to be 0.1. 0.1 might be sufficient, or 0.10. If I needed to add, and we'll just accept that. Or if I were to add another one on the other up at the top here, and we'll go to that point. Or if I tab it over, or I don't like it laid out like that, I want to add let's see. We'll keep that in now. Notice now my browser tree is starting to give me some information here. All right. I could turn on at the bottom here my face status coloring, so I can see what areas are fully constrained. So I see, okay, this other side is not fully constrained. I need to make sure I define that. So I will add another tolerance feature over here. We'll accept that, and it'll be a profile note. And we'll just, we don't want to turn another segment on, the C or not, and accept that. So now that is fully constrained. And I might need to make sure that the bottom feet are coplanar, so I could continue to add more tolerance features in there if I would like. But I think for the moment we've given you a good idea how the tool works. Just real quick, surface textures available. If I needed to add a leader note, maybe say, break all sharp edges, I could do such a thing here, and say, dialog appeared on my other monitor there. We'll break sharp edges 0.05 within 0.05. There we go. There we go. Or general note. What general note is, or general profile is, it's adding a general note or comment in a quadrant, in this particular case, unless otherwise specified, and it's a specific property, which in this case, the profile tolerance is applied. I can modify what that property is by selecting right from here, if need be. And it's a note that will appear. So then when I, for example, collaborate, and maybe I'm just going to use a shared view from my Collaborate tab. I'm just going to use a shared view now, and I'm going to share this view to the manufacturing department. They'll be able to see it. But real quick, because I want to stay on target here time-wise, right-click in the drawing views and retrieve those annotations, and we're good to go. Same thing here, and so on. And get my annotation note there as well. So, all right. So we're down to so a little bit longer here. I'm talking a little bit more, I think, here, but let's get into the next part of our presentation, which would be tolerance Stackup. And I'll speed things up a little bit here because I don't want to, I might go a couple minutes over. I hope that'll be okay, Cassie. So let's get over, let's just skip that slide here, and let's just get into the meat and potatoes of tolerance analysis. So you saw Tolerance Advisor from the annotation tab within a part, guiding us through how to make sure we have tolerances defined properly within a part. Well, all of those, many of those annotations can come across into Tolerance Stackup. Tolerance Stackup, it's a subscription benefit for product design and manufacturing collection subscribers. You can download and install this plugin from your Autodesk subscription account. Tolerance Analysis helps you measure tolerance stackups in your 3D assembly to more accurately predict the level of tolerance you need to apply to the individual parts while ensuring all parts will consistently fit together. So in this particular case, we have three examples. In the worst condition, I have a nominal tolerance. My model set up in a nominal tolerance where the size was designed. The models is designed as per the dimensions in the, or are placed as per the dimensions in the model. There could be a minimum condition and maximum conditions that you may need to analyze. So will these two buckets fit in this gap if each of the part is to a maximum width? How much of an interference will I have? If all the parts are to a minimum width, what's the maximum gap that I will have? So let's take a quick look at this type of an analysis here, and I'll go right back into Inventor, and let's just open up from my vault. I'll open them both up. All right, so back to the Annotate tab. Now we have a tolerance analysis at the assembly level. Turns on yet another tab. I could dock this tab inside of my browser tab here. I choose to keep it for something that kind of highlights it for us a little bit better. What I do is I want to start defining a stackup. So just briefly, how does tolerance analysis work? So I need to tell the system where my initial gap is at, or where my initial fixed position is. So based on this face, and well, software won't highlight any of these faces. It'll only highlight something parallel to the face that I've selected. All right. Where do I want to put that initial dimension? Because I will be adding a little bit of information to the model. I need to select where I want to locate it, and how can I want to find, because we're dealing with, in this case, a one-dimensional tolerance stackup analysis tool. We don't get 2 or 3D dimensional stackups with this current version. So along and in one direction along this axis, the x-axis, I can select a path, and the path was found based on how this model was assembled. And the software tolerance analysis looks for mate constraints. So now the system found those constraints and dropped in the other dimensions. So now we get our analysis browser filled in where I can step through, and I see a couple of links here. These parts, tile 2 and tile 4, are linked based on their annotations. Things I can do: change the tolerance type, because I need to, first of all, see the worst condition is, well, there's going to be plenty of space here. I can change to a worst condition, an RSS type condition, which is a root sum squares, or a few different statistical type. Those of you that are do a lot of tolerance stackup analysis, maybe using Excel spreadsheets or other software, may be familiar with these particular options. I'm going to be presenting worst case scenarios today, though. So this is just basically how we start and begin to build a tolerance stackup. Now, let me get out of this here, and let me get into my next model. And what we'll do here is we'll get into the same thing, and because I'm short on time, I won't go back into the PowerPoint. So I'm just going to speed along a little bit here, and let's do again another analysis. This one's got a few more parts in it, so we'll add. First of all, I can go through my settings, talk about that, and I can determine whether we're going to deal with inch or metric units. If I have millimeter units selected and a part is designed in centimeter units, tolerance analysis will convert centimeters to millimeters for you, or to inches. It'll handle the conversion for you. So we can determine what the default analysis type will be, and some default colors for some of the information that's displayed on the screen. So let's create a stackup. And in this case now, I'm going to pick, and there's my gap. I'm looking right in this area here. So I'm going to pick that face there because we're asked for a plane. And now, as I pick, it allows me to pick the next plane, and I need again to specify where I want it to be annotated. Let's see. That looks like it's about right. All right. Again, now it found a path of assembly constraints. I could select and say, well, I want to go from and start picking faces, this face here to the face over on the back side of this wheel or of this bearing, or I can say, let's go back and let's use the assembly path. Why would I use the select option? Because maybe I imported an assembly and there are no assembly constraints, but the parts are going to be locked in position, and I'm going to do an analysis based on that assembly. So here I'll use my existing path, and I see there are several mates in there. As I highlight, so the system looks for the Inventor mate constraint option. Not the insert, unfortunately, in this particular case. It does look for a joint constraint also, so assembly constraints and joint. So let's pick that and go for it. And system going off in one direction, we'll start analyzing the tolerances, and then all the way back, including the gap, we have a total of 1.57, and we have potentially, in the worst case scenario, a 23,000th interference that could take place should every part be the maximum thickness and the shaft be the minimum distance between the gaps. Now, what can I do as I pick on each part? It highlights in the browser, I have to pick on the part here or the dimension here, and it highlights on the screen. So I can change the tolerance to geometric tolerance, a limits tolerance, what tolerance I need. Maybe in this case, my shaft. Where's my shaft at? Let's make our shaft be, well, that's going to be a plus minus tolerance, and it's going to be plus 10 minus 0. So we're 10 thousandths better. Due to time, we can go through and change everything, but due to time, I'm going to we'll change our spacer and we'll make it be 0.01, and we're down to 3 thousandths. Things I can do from here, I can add additional features. So if there was another feature that I added into my design or that I missed in the initial because I was using the select option, I can add a feature. Maybe I want to tell the system that there's going to be a gap over here, so I can create an offset if I need to. I can generate a report, and I can take snapshots at various stages of the analysis. So I'll take a snapshot. said show snapshot. I mean take snapshot. There we go. Take it. That's all there is to it. No prompts, no nothing. So now when I go to my report tool, it generates an HTML, asks what file to save it to. I'm going to call it report_A. And what will happen then, I thought I said report A. There we go. There we go. Didn't do something right. And it brings it up in our browser. So this is very quick where we started. Some of the conditional information, not too much in that particular case, because we kept this one simple, went through it kind of quick. Stackup number one, I can create additional stackups and have using the other types of options, an RSS or a statistical type. The report here shows the tolerance types. If there were GD and T, those would be appearing here as well, my units and so on. So some report information. What parts are the largest or least contributors to the stackup? Okay. And the last thing here, let's get back into our PowerPoint here. I'm just going to go right to the end here. All this information that we talked about, tolerance analysis, the annotations, carry over to Inventor CAM as well. So because one of the Autodesk has integrated CAM for drilling, milling, turning, 5-axis, even nesting is integrated into Inventor now. Separate applications that you have to acquire, but they are sometimes part of the collections as well. We talked to our salesperson about that. But the point that I wanted to get across here is that I'm doing all that annotation work, and now I can simply bring those Inventor files, open them up in my Inventor CAM, and that symbology will appear here. So I can start to apply these notes to my manufacturing tools. I don't have to get a detailed drawing. Again, I think you get the point. When you need a drawing, when you won't make a drawing.